How do you deliver high performance for SQL Server with ultra low latency? This short video is going to show how we're enabling SQL Server to run faster, perform more consistently, and scale larger. The technology we're leveraging is the Windows NVMe over Rocky or RDMA driver to the Pavilion storage array, delivering impressive NVMe and NVMe over Fabric performance. In an example, in this test environment, how we've started small and delivered very, very impressive results with a fraction of our system's performance. Another benefit of our NVMe over Fabric driver for Windows is we're seeing a lot of adoption for the leverage of SQL Server acceleration. We have two customers, one a large hedge fund, another one a large service provider in the financial, both of them, of course, in the financial sector, is we're driven by the need to scale SQL Server consistently and predictably. This is enabled by the Windows NVMe over Fabric driver, again, that low latency, high bandwidth. Typically, these environments have been legacy DAS because of performance reasons. They want to move to shared for flexibility and consistency. And again, that enabled by this predictable, consistent, high performance. The great use case of this is you can start small and grow big. You can independently scale capacity and performance, and that gives you that flexibility. These customers are starting with maybe one SQL Server, putting its workload over 5 of our controllers connected to one of our zones or media groups of storage. And as they need another SQL Server, they can dedicate another 5 controllers to that SQL Server and have its own set of disks. Continue with Server 3, continue with Server 4. This allows that linear, predictable performance, almost to the context of multi-tenancy, and having a quality of service such that each one of these SQL servers is not impinged upon any performance or anything as it relates to any one of the other workloads. Ability to start small, grow big. Let's look at some real-world testing results as it relates to testing SQL Server in a very high-performant environment for one of our customers. And in this case, very high-performance SQL Server with direct attached storage, and they wanted to compare how that related to putting it to an external shared storage array like Pavilion. In this particular test example, they direct connected the server to our storage array. But in real-world practicality, if it were in a network-based environment, it would have minimal to no impact on performance, whether that's throughput or IOPs, and minimal to no performance as it relates to latency. But this is a comparison of direct attached storage to one of our Pavilion shared storage arrays. You can see the specifications, a pretty beefy Supermicro server with 100 gig Mellanox ports populated to a small version of our Pavilion storage array, which contains 2 of our line cards, which means 2 independent controllers each. So that's 4 controllers to 18 of our drives. That is the test scenario running the Windows NVMe over Fabric driver that is using RDMA. So let's look at the test results. And these are performance test results based upon the environment in the previous slide as it relates to SQL Server and a representative block size testing from one of our customers. A larger block size, 64K, and a smaller block size, 8K. The test was, what could we do from a bandwidth perspective on the larger block size, and what could we do from an IOPS perspective on the smaller block size. In each one of the tests, we gave a first row as the smallest that the customer requested that we do and what latency we can be at that. And then as we did to the IO size, what was kind of a middle performance, as well as what could we do from a max IOPS performance. So that you can see from a read performance, as we look at max of each of these, 14 gigabytes a second at 200 microsecond latency. From a write perspective, again, large block size, 8.3 gigabytes a second at 1.5 millisecond latency. When we look at read, we maxed out at 1.7 million IOPS at 138 microsecond latency. Our write IOPs maxed out at 500K IOPs at a little less than 1 millisecond latency, 0.95 milliseconds. And as we look at that, remember, that's not a full Pavilion box. That's a single server with 400 gig ports to 2 of Pavilion's line cards, or 4 of our controllers, and 18 of our drives. So in other words, almost little less than 1/4 of one of our systems. Very impressive numbers. Here are the numbers as it relates if we turn our 128-bit encryption on and or we turn on our 256-bit encryption. Still with encryption, pretty incredible performance, whether it's the large block size from a throughput perspective or the smaller block size from an IOPS perspective. So this is an example of starting small and being able to scale this larger with impressive results for SQL Server leveraging the Windows NVMe over Fabric RDMA driver. To learn more about us, check out our website at pavilion.io.